my class. My name is Jyoti and you are watching JG Chemistry. So students, today we are going to solve some problems from pericyclic reactions. In that we will focus on electrocyclic reactions and will learn the concept. For that, do subscribe my channel and press the bell icon so that you will get the latest notification of my videos. Do like it and share it with your friends so that it will be helpful for them also. Okay, so let's start. Okay, so first, what is electrocyclic reaction? So as you can see here, we have written some symbols. This represent the thermal, TH for thermal, PH for photochemical reaction, which we represent by H nu. And there are two type of system here. It may be 4n system in electrocyclic reaction or 4n plus 2 type of system. Okay, and there are two methods of as this is the method of the reaction under thermal or photochemical reactions of conjugated polyenes to form the cyclic compound, or opening of a cyclic compound is called the electrocyclic reaction. So ring closure or ring opening reactions occur under electrocyclic reaction. So there are two methods to close the ring. It may be conrotatory or it may be disrotatory, or opening the ring, conrotatory or disrotatory. So this is the table, or you can say the selection rule, which we have to keep in our mind to solve the problems and its stereochemistry correctly. For that, you can just learn this trick 6 pi PC, which will be helpful for you to keep this table in your mind, right? So if you learn 6 pi PC, it is very helpful. As you can notice here, for 4n system under thermal condition, the ring, the conrotatory ring closure or ring opening will occur. Under photochemical condition, it is disrotatory for 4n system. For 4n plus 2 pi system under thermal condition, it is disrotatory. Photochemically, for 4n plus 2, it is conrotatory. So one thing you can notice in this table, like if you learn 6 pi PC like this, you are working on PCs right now, isn't it? During this online period, PC, 6 pi PC, 6 pi PC. So P for photochemical. So for 6 pi system under photochemical condition, the method is conrotatory. So it is just reverse in thermal condition. You can notice it is disrotatory. Now if for 6 pi system, which is 4n plus 2 system, photochemically conrotatory, then for 4n system, photochemically it will be opposite, disrotatory. And if it is photochemically disrotatory, means for 4n system under thermal condition, it is opposite to this, it is conrotatory. So if you notice this behavior here, and if you keep in your mind this is small 6 pi PC, then it will not be tough for you to keep this selection rule in your mind. Now we will see how to do this conrotatory and disrotatory method. Okay, so these are the two methods here. Conrotatory, you can see if the conjugated system on the terminal carbons, the symmetry is asymmetric. Okay, if asymmetric, one side, the low base, you can see the shaded part is above the plane, the other side it is below the plane, asymmetric orbitals, then the ring closing will be conrotatory method. Conrotatory means either you can do in the same direction or clockwise or anti-clockwise. Okay, so that it can form a bond, right? Shaded part will form a bond. So this is only possible if you rotate it either clockwise or anti-clockwise. As you can notice, conrotatory means here, this is again a small trick to keep in your mind, that if it is a conrotatory ring closure, then the change in stereochemistry will happen. If you are starting with your cis reactant, you will get the trans product. If you are starting with trans reactant, you will get the cis product. And how to keep in your mind, as I have underlined here, C and C. C for conrotatory, C for change, stereochemistry. Okay, and one thing is asymmetric here. And if you know about symmetry, it is having the C2 symmetry. So you can keep in your mind that also, C2 symmetry, conrotatory and change. The other method is disrotatory, when the terminal orbitals are having the shaded lobe on the same side. Okay, and if to form a bond, it has to move opposite to each other. You can notice one is in clockwise, other is in anti-clockwise, so that it can form a sigma bond. Disrotatory, there is no change in the stereochemistry. If you are starting with cis reactant, you will get the cis product. If you are starting with trans reactant, you will get the trans product. So basically, and you can notice here symmetric means here you can notice it is having the symmetry, plane of symmetry is there. So if your molecule is having a plane of symmetry, then this rotatory ring closure will occur. So basically this electrocyclic reactions are completely stereo selective reactions. And you can notice it is the intramolecular reaction where a new sigma bond is forming. Okay. So these two things we have to keep in our mind. This is the concept to solve the problems of electrocyclic reactions. Okay, now we will focus on the problem. So this is our very first problem. As you can see here, this is the 4n pi system. The two double bonds are there. So each double bond having the 2 pi system, 2 electrons, so total 4 pi system. 4 pi system, and I have done the numbering here. We always select the longest chain. So you can notice here we are starting here from methyl, which is the carbon, okay, CH3. So this is the substituted diene, all right. So we always start from the longest chain. So it is the 6-membered chain, right? And if why we have done this numbering here, because for M.Sc students sometimes they give the name of the molecule instead of the structure. So if they have given you the name of the molecule, you have to draw the structure yourself. So this is very important, because if you draw the structure wrong, then your entire reaction is going to be wrong. So you can notice here, if they have given you 2E4E hexadiene, E means trans, Z means, so this is EZ, okay, configuration, Z means cis bond, double bond. So 2E means here the at 2 carbon, you can notice this the hydrogen, the position of hydrogen at 2 carbon and 3 carbon is opposite to each other, means it is the trans. So 2E, and similarly for 4 carbon, you can notice the position of hydrogen is opposite, means this is also a trans double bond. So 2E, 4E, hexa means 6 carbon, hexa and 2 double bonds, so diene, 2E, 4E, hexadiene. So this is the name of this molecule. And so the possibility is you could have written this in place of H, then it will become cis, right? So if you write it in place of, so if you interconvert it, then the 2 hydrogen will remain on the same position. Then the other structure will become 2Z and 4Z hexadiene. Now, why we have written here cis, how to define this overall stereochemistry of this product, so reactant, so that we can govern the stereochemistry of the product, right? So for that, again, we have a small trick that you can notice here, the substituent at the terminal carbon, both are outside, right? So both are outside, we consider it same. If both the substituent are inside in place of hydrogen, then also we will consider it same. Same means cis. If one is inside the substituent and one is outside, then we will consider it different, and the stereochemistry, overall stereochemistry, we will consider as trans. So since in this molecule we have Me as outside, both are outside, it is considered as same, means cis. So we can write the stereochemistry is cis. And the 4n system, under thermal condition, they will mention you the condition here. Under thermal condition for 4 pi system, now we have to keep remember the selection rule. So 6 pi PC is a trick. So photochemically, for 4n plus 2, it is conrotatory. Then for 4 pi system, photochemically, it will be disrotatory. So obviously for thermal condition, it will be conrotatory. So this is how we, just from 6 pi PC, we brought that for under thermal condition for 4 pi system, it will be conrotatory ring closure. And if it is conrotatory, there will be change in the stereochemistry, means the cis will give you the trans product. So that we will see. Before that, we will see normal electron migration. So to for the ring closure. So you can notice here, conrotatory means in the same direction, and the terminal orbital will be asymmetric, as we have noticed already. So it is the long method. Okay, for MSc student especially, they have to draw the mechanism. So if they are asking you draw the mechanism, then you have to mention the orbital symmetry, right? So if it is conrotatory, you have brought it, means you have to draw the terminal orbital with opposite side shaded lobes, right? And so the red arrow mention you the conrotatory motion, and the blue arrow indicates you the electron migration. So in that, we can draw the simple cyclobutene ring. You will get a new pi bond formation and a new sigma bond formation. So if you notice, your reactant is having 2 pi bond and the product is having 1 fewer pi bond. Okay, and a 1 new sigma bond is there. Now the stereochemistry of the terminal methyl, as I told you, if it is conrotatory, the cis will give you trans and the trans reactant will give you cis. So directly you can draw the trans without writing this intermediate also. Straightforward. Since we have a less time in the competitive exam, so you have to just mention the final product, okay, which is the correct structure. You have to just mention that. So a short trick to do that. But for MSc students, they have to write down the intermediate. For that, they have to write this orbital structure. And as you notice, you can notice also, if you bring this bond down, the Me is coming above the plane. And here, if you bring this shaded part here, okay, from clockwise this rotation, the Me is coming down the plane. So one Me is above the plane, other is down the plane, means the two are opposite to each other. We are getting the trans product. So this is a longer method which will require the time, because you have to draw this. So this is orbital picture is for them, those who are writing the mechanism. Okay, otherwise for competition, straightforward, you can use the trick. This is our next problem, and you can notice here in this problem you have 3 double bond, means 6 pi electron system, that is 4n plus 2, okay, system. The condition will be given to you. One more thing we have to notice here, the position of Me, one is inside, other is outside, which will be considered as trans, right? So the overall symmetry will be considered as trans, and the condition they have given under thermal condition, 4n plus 2 system. So under thermal condition, so if we remember 6 pi Pc means for 6 pi electron, photochemically it is conrotatory, so thermally it will be disrotatory. So basically under thermal condition for 4n plus 2 system, it is disrotatory ring closing reaction. Okay, so this is the orbital picture for disrotatory terminal. Orbitals are having the same side shaded, okay, and the orbitals are moving opposite to each other to form a bond, a new sigma bond, and you can see the migration of the electrons. Here again you can notice this shaded part will come down. Okay, so now disrotatory means there is no change in the stereochemistry. The trans reactant will give you the trans product. So directly you can tick your answer, the trans product. But for those who are writing the mechanism, you can also see here, if you bring this bond here to form a sigma bond, the Me is going down, and here also if you are bringing this shaded part here, the Me is going above the plane. So one Me is down, other is above the plane, the two are opposite to each other, therefore the product is trans. Okay, so for competitive exam, you can directly use a short trick and bring the stereochemistry. For those who are attempting the mechanism, for them they can use this mechanism also. Okay, so the next problem is our having total 8 pi electron system, which is again 4n system. 4n system, and you can see here the two substituents are outside, we will consider it same. So the overall overall stereochemistry we will consider cis. They have mentioned the temperature, means it is thermal condition. So under thermal condition for 4n system, it is conrotatory, right? Just remember 6 pi Pc and you can bring it. Conrotatory means change in stereochemistry. The cis will give you the trans product, right? So you can notice the reactant was having 4 pi bond. Now here you have only 3 pi bond. So one fewer pi bond with one new sigma bond formation, and you can mention the stereochemistry of the two substituent as a trans. But this is not the final product here. As you can notice, is still the electrocyclic reaction is possible here. This is the 6-pi system, so you can do the ring closing reaction also. So ring closing reaction under thermal condition for 6-pi electron, it is disrotatory, right? Disrotatory ring closure means there is no change in the stereochemistry. Now we don't have to bother the stereochemistry of this CO2 Me, because we always consider the terminal carbon of the pi bond. So terminal carbon is having the hydrogen, and the two hydrogens are cis to each other, right? The two hydrogens are both are outside, considered as cis, means disrotatory ring closure. Cis means you will get the cis product here. It means the position of the hydrogen you can make either above the plane or below the plane, same side, right? Here again the 3 pi bond you are giving the 2 double bond in the product. So this is the correct way to represent your answer, right? So stereochemistry we are mentioning here directly, it is the short trick. This is our next problem. Here you notice what we can do here. Okay, what we can do here, you can consider it as we know electrocyclic reactions are reversible reaction, right? Reversible reaction means this acyclic reaction will give you the cyclic product, and the cyclic will give you the polyene, conjugated polyene system. So if you think of this structure, it could be the 6-pi, this could come from the 6-pi system, right? Like we have done here, isn't it? You are getting from this 3-pi bond, you are getting the 2-pi bond, which is the fewer bond. So 6-membered ring, this one, right? So if you consider that, okay, because it can't be 4-pi system. If you do that ring closure here, it will create a 2 4-membered ring, which is highly strained, unstable. So unstable products are not going to form. So the reaction occur always to try to form a more stable product. So we will consider to open this sigma bond, right? And here you can notice the position of the methyl group is both in the same direction. So the stereochemistry is cis. So they have given you the condition photochemical. So total number of electron we will consider 4 from the pi bond and 2 from the sigma bond. So total 6-pi system. 6-pi system photochemically we know it is 6-pi PC conrotatory, and conrotatory means stereochemistry is going to change. Cis will give you the trans product, right? So you will get here trans. You can write down the hexatriene simply, and trans means the position of Me you can write down, one is inside, other is outside. So this is the product of this reaction. In that way you can save your time. Now this reaction, if they give you, it is kind of a conversion. Okay, so you can notice here the 2 dots represent the position of the hydrogen is same side, it is cis, and in the product we have the trans. Okay, so bicyclic product we are having. Now we have to find out the conditions and intermediate here. Okay, so again if we consider it is the 6-pi ring, okay, 6-pi system, so it is going to be ring opening reaction. Okay, 6-pi ring opening. Since we have, this is cis system and we want our product to be trans, means stereochemistry we want it to change from cis to trans, and stereochemistry only change for 6-pi system if it is photochemically, right? Because we know 6-pi photochemically is conrotatory, right? So conrotatory ring opening means it is going to change the stereochemistry, and you are getting the trans hydrogen here. So to represent that, you can see here one hydrogen is inside, other is outside. This double bond is trans, the other 2 cis. And the terminal carbon proton is also, one is inside, other is outside, means it is trans hydrogen. But again the reaction is not going to stop here. It is the open 6-pi electron system. Again the electrocyclic ring closure will occur. Since we want trans here and our reactant is also trans product, so we want it to close thermally. This 6-pi system disrotatory, ring closure, because in disrotatory the stereochemistry doesn't change, the trans reactant will give you the trans product. So in that way you can solve this kind of problems also where they have not mentioned you the conditions. Okay, so this is another problem where you can notice the stereochemistry is also mentioned here. And if you notice here, this as a 6 pi system, okay, 6 pi system, then it is going to create another 4 membered ring here, which is highly strained, unstable, so we cannot consider it as a 6 pi electrocyclic ring closure reaction. That is not possible. 170 degrees centigrade is given, means it is under thermal condition. So we can consider this as a 8 pi electron system, okay, that is 4n system, 6 pi electron from the double bond and 2 electron from the sigma bond, right? So if you consider that under thermal condition 8 pi electron, we know it is conrotatory ring opening. We can show the electron migration here, and overall symmetry you can see here. The position of hydrogen is mentioned here, it is cis. So conrotatory cis will give you the trans. So this is the intermediate. You can notice here where you can notice one hydrogen at the terminal carbon is inside, other is outside, so it is trans. Overall stereochemistry is trans. So this is in a square bracket, means it is not the final product. Again, the thermal condition on heating, you can do the 6 pi electron ring closure here, and thermal condition 6 pi, it is disrotatory, so ring closure, the stereochemistry will not change, the trans will give you the trans product here. Okay, so you can notice here the dot on the one side means it is the trans, the position of the two hydrogen is trans to each other, and there is two possibility to write it. Either you can do this above the plane or the down one as above the plane, so the both are diastereomers to each other. And you can notice here 6 pi system is giving you the 4 pi, one fewer bond and one new sigma bond. And now this system is stable because it is generating one 6 membered ring and another is 5 membered ring. So this is the product and our final reaction for today's discussion. That's it for today. See you in the next video. Till then, bye bye.